Hi, Math 3 students. Today we're going to be going over multiplying and dividing rational expressions. It's very similar to just simplifying rational expressions. Essentially what you have to do is factor everything, and then if there is anything on both the top and the bottom, it cancels. So that's pretty much how this works. And you have to keep in mind that when you multiply things, I guess we could do it here. I'll show you real quick. Let's say I had this is a good example to start out with. Let's say I had 1/2 times 1/3. Okay. When you multiply, right, you multiply the top numbers and then you multiply the bottom numbers. That would give me 1/6, right? Now, if I was asked to divide this, when you divide, you keep, change, and then flip. Then you just go ahead and multiply. So you keep the first fraction, change the division sign to a multiplication, and then flip. Oh, I don't know why I put a 2 there. That ain't right. Sorry. So you flip that second fraction. So then we go ahead and do 1 times 3 is 3. 2 times 1 is 2. And the answer for division would be 3/2. So it's important to keep in mind that for multiplication, you just multiply across on top. Division, you flip the second fraction and then multiply. All right. So now what we have to do here is we're essentially just going to go ahead and factor the heck out of everything here. So I've got a 3. I can't do anything with a 3x. All right. Then on the bottom here, I can take a GCF of 2 out. Okay, I can take a 2 out of 2x and a 2 out of 2. When I do 2x divided by 2, I get x. When I do 2 divided by 2, I get 1. Then if I look here, this guy is what we call a difference of squares. So we end up with x plus 1, x minus 1. Then on the, actually I guess I could emphasize on that. How do I know this is a difference of squares? We've got a minus sign. And we also can take the square root of both of these. The square root of x squared is x. The square root of 1 is 1. So it follows that factoring pattern of x plus 1, x minus 1. Then we've got a trinomial here. We got to figure out what multiplies to this guy. Oh, I can't spell. Multiplies to this guy, adds to this guy. That is going to be, let's see, x plus 7, x minus 1. That took me longer than it should have. All right. So now when you multiply things, right, you just multiply the top and the bottom. Now, in some cases, you could go ahead and FOIL, distribute, all that, but we're not going to do that here. All we have to do is, and I will kind of point out that this step is kind of almost unnecessary once you learn how to cancel. But essentially what happens is everything on the top stays on the top, everything on the bottom stays on the bottom. All right, so I did this times this. Again, could you go ahead and distribute and FOIL and stuff? You could, but you don't want to do that because we want it to be factored, which allows us to cancel things out. So then we look and we're like, okay, is there anything that is on the top and the bottom that we can cancel here? First, you would look to see if you could cancel 3/2. Simplify it at all. You can't. Then I've got an x plus 1, x plus 1, x minus 1, x minus 1. So on the top, I am left with a 3x. And on the bottom, I'm left with a 2 times x plus 7. All right. This is an acceptable answer. You also, let's say they wanted you to simplify that further, you could and distribute, and you would get 3x all over 2x plus 14. These are both acceptable answers. All right. When you take standardized tests like the SAT, you should be able to kind of identify that these are equivalent, and they might give you either or as your solution. All right, let's try this next one. So we've got x plus 3. I can't do much with that, right? But on the bottom here, I can do x plus 3 times x plus 4. That's what multiplies to 12, adds to 7. And then I've got x plus 4, x minus 3. Again, what multiplies to negative 12, adds to 1. All right. And then on the bottom here, I've got a GCF of 3. So I'm going to take a 3 out and I get x minus 6. All right. So now, again, remember how I said that this step here where you combine them is unnecessary? You can do this. However, as long as you understand that anything on the top can cancel with stuff on the bottom, you don't have to rewrite it. I can just look and say, okay, well, I've got this guy on the top, this guy on the bottom, this guy on the top, this guy on the bottom. So as soon as you factor, you can go ahead and just cancel stuff without rewriting it. For multiplication. Division, you do have to make sure that you flip it. All right, so then we are left with an x minus 3 on top, and then a 3x minus 6 on the bottom. All right. Okay, so now let's go ahead and do some of these division ones. All right. Now, again, I want you to think back. When you divide fractions, you keep the first guy the same. You change the middle guy to a multiplication. You flip the second fraction. So let's go ahead and try this. First one, we got a difference of squares here. I can take the square root of both of these, and I got a minus. So it's going to be x plus 4, x minus 4, all over. And then I got a 2x minus 18. I can take a 2 out. I get x minus 9. Then I've got a x minus 4, x plus 2 on top, right? Because I got to figure out what multiplies to this, adds to this. And then I can go ahead and I got x plus 2 on the bottom. Now, I cannot cancel right now because I need to flip my second fraction. Now, I don't care when you flip it. Some people at this point would have already flipped it. So like instead of writing it like this, I could have went, well, I'm just going to flip it right now in my head. Change this to a multiplication sign. You can do whatever you want, right? You can go straight to this. You could write it that way and then rewrite it. I don't care. Whatever works for you. So then we go ahead. Now it's just simply a multiplication problem like we were doing before. And when it's multiplication, you can go ahead and just cancel stuff out that's on the top and on the bottom. So here, I've got an x plus 2x plus 2. Here I've got an x minus 4 and an x minus 4. So on the top, I am left with an x plus 4. And I get 2x minus 9. And again, you could write this. You could distribute this back in there if you'd like and get 2x minus 18. That would be an acceptable answer as well. All right, next one. So we'll go ahead, factor this first guy. So I get x minus 5, x minus 4, all over x minus 5. How did I get that? Well, what multiplies to 20 and adds to negative 9? That's going to be a negative 5 and a negative 4. Then I can go ahead, change this to multiplication, and flip. So I'm going to now put this bottom guy on top. So if I look at this bottom guy, I have a GCF of x. So I'm going to take an x out. All right. And then my top, which is now my bottom, is going to be, it's a difference of squares, x plus 4, x minus 4. All right. So now we got to cancel everything that we can here. Cancel, 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 cancel. Cancel, cancel. The only thing left is an x on top. So it's just x. All right. If the x had been left on the bottom, then we would have had to put a placeholder on top. So let's say hypothetically we had ended up like, I don't know, let's just say we had 5x, right? Where like all you're left with is an x on the bottom. That would be written as 1 over x. Okay, if there's nothing left on the top, you have to put something there, so you put a 1. So don't forget to do that. But you don't have to put anything on the bottom, right? It's the idea that like you can write the number 2. You can write it as 2 over 1, but we don't. However, 1/2 has to be written as that, right? Or else you would think it's a 2. So yeah, all right, that's that one. All right, let's keep rocking and rolling here, friends. Okay, so this first one's going to be a little bit ugly, I think, here. So first, let's go ahead and take a GCF out. So if I take a GCF out, I know I can take a 9 out. Let's pull up a calculator here. So if I take a 9x out, I end up with x squared minus 5x, and then I think 126, what is that, 14 divided by 9? Let's see. 14, yes. So we get minus 14. So we are going to have to factor that one a little bit further, but that's a-okay. Let's see, I'll just rewrite this as to not confuse anyone. Times, and then we could factor this guy on top, I guess, right? X squared oops, x plus 5, x minus 5. And then on the bottom here, I got to take a GCF out as well of just x. So I get x squared minus 12x plus 35. And then these trinomials, I have to go ahead and factor further. So we're actually going to have to write this again. So we get 9x. And then let's see, x minus 7, x plus 2, right? Because we got to figure out what multiplies to this, adds to this. And then x plus 5, x plus 2. And then this was multiplication, right? So we don't have to flippity flop or anything like that. And then this guy, we've got x minus, let's see, 5. What is that? 7 and 5, right? X minus 7, x minus 5. All right. So now let's go ahead, see what cancels here. It seems like a lot's going to cancel. So first off, these x's cancel. All right. Ooh, did not mean to erase. These x minus 7s cancel, right? Because we got one on the top and one on the bottom. These guys cancel. These guys cancel. These guys cancel. Oh my, the only thing left is a 9 on top. So it's literally just a 9. All right, all that work for a 9. Crazy. All right, next one. So first, let's go ahead. Let's take out all of our GCFs first. This first guy, we can take a 2 out. So we get x squared minus 9 all over. In this bottom guy, we can take an x squared out. We get x squared plus 2x minus 3. I can't do anything with this guy here, so we could just go ahead and factor him right off the bat. X minus 10, x minus 1, same thing here, x minus 10, x minus 3. Now we got to go ahead, this difference of squares in this trinomial, we have to factor a little bit further here. So if you notice, some of these have two-step factoring problems, which you guys are totally capable of doing. It just takes a little bit of extra effort here. Let's see, x, so this one was a difference of squares, right? So we take the square root of both of these, x plus 3, x minus 3. Then this bottom one multiplies negative 3, adds a 2. That's going to be x plus 3, x minus 1 times x, oops, minus 10, x minus 1 all over, x minus 10, x minus 3. All right, and let's cancel, cancel, cancel. So we get do-do, 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 do-do. And we are going to be left with a 2 all over x squared. So that'd be our answer here.